to read the blurb here, which tells you that ABCD is a trapezium rather, and we can see that AB is 12A, DC is the same as 18A, which is as we'd expect, and AD is 3B. And they tell you that E is on this diagonal, so that DE is a third, so the distance from there to there is a third of the distance from there to there, and I'm sure we'll use that later. Okay, first of all, to find DB, okay, DB, well, to go from D to B, I don't know what it is in terms of little a and little b, but if I go from D to A, so I'm going to go from D to A, and then I'm going to follow that, which remember for vectors means adding, so DA plus AB. Okay, so the vector DA, well, 3b goes from A to D, so DA is going to be minus 3b plus AB, which is 12a. So I'm going to write now that DB, it's really useful to remember what it is you found, is 12a minus 3b. Okay, next thing says find DE. Well, to find DE, I'm going to use this fact that they gave me here, the fact that DE is a third of DB, because it just so happens that I have just found DB, so I'm going to do a third of DB, and DB is 12a minus 3b, and it's quite easy to find a third of that because they're both multiples of 3, so a third of 12a, well, that's 4a, and a third of 3b is just going to be b. So I've now found the fact that DE is equal to 4a minus b. Right, question now says find AE, and it's always useful to look at what you've just found. AE, I've got a choice of ways that I can go for AE. I could go that way round, so I could go that way round, or I could go that way round. But if I choose carefully, I am going to use the one which is most useful to me, and I have just found DE. So I'm going to go from A to D and then from D to E. Okay, so for AE, I'm going to do A to D, and then I'm going to do D to E, because I already know DE. Okay, the vector AD, if we look at that, it's this 3B. Oopsie. So it's going to be 3B, and the DE, as I've just said, we've just found it, so it's plus 4A minus B. And if we work that out, 3B take away B, well, actually that is 2B and then plus 4a. So I can see from that that the vector AE, let's just write down what I found, AE is 2b plus 4a. Question now says find a vector method to show that BC is parallel to AE. Well, surprise, surprise, I have just found the vector AE, and AE is the same as 4a plus 2b. Let's write it the alphabetical way because it's probably going to be easier. And if I want to use a vector method, I know the vector AE, I'm going to find now the vector BC. Okay, so let's try to find the vector BC. Now, to go from B to C, I'm going to go the long way round. So BC, I'm going to go BA. So BC, I'm going to write it up here. So BC is going to be BA, followed by, so add AD, followed by DC. Okay, so I'm going to go B to A this way, and then that way, and then that way, and that takes me all the way from B to C. So the vector BA, now notice it's in the opposite direction to the 12A, so that's minus 12A. AD is this vector here, which is 3B, going in the right direction, and then DC is this one, which is 18A. And if we simplify that, well, minus 12A plus 18A, well, that's the same as 6A plus 3B. So I know that BC is 6A plus 3B. Okay, let's just write that down here. So BC is 6A plus 3B. Now, if I look at these, go back to AE, if I take out 2 as a common factor there, so it becomes 2, and then it's times 2A plus B. So the vector AE is 2 lots of 2A plus B. And I can see for BC, if I take 3 out as a common factor, then it becomes 2A in the brackets plus B. From this then, I can see that AE, the vector AE is a multiple of the vector BC, so they are both multiples of 2a plus b. Therefore, and if we know that if two vectors are multiples of each other, then they are parallel, so AE is parallel to BC, which is what we want.